All right, so to kind of expand on what we did on Friday, so what we're going to do is I'm going to do the I do, all three of them, A, B, and C, and then I'm going to give you guys a chance to go in and do the rest of them. We're going to kind of work them out together to make sure we're all on the same page, all right? So the first one is CrCl3. So if they give you this, what do you think you're going to have to do? We're going to have to name it. So my first question is, matter of fact, Brett, do me a favor. Will you pass everyone down the periodic table, please, sir? That would be beneficial. Robin, I'm going to start with you. We're just going to work our way down the road. What is Cr? Chromium, all right? Robin, is chromium a metal? Yes or no? Start with Robin, please, if you don't mind. Brett, start on that side because I'm going to work my way down that way. He can have that. It is a metal. All right, Robin, what is Cl? It's a chlorine. Is it a metal or a non-metal? It's a non-metal, and I've told you this from the very get-go. The number one thing that you have to do first. What's wrong? This should be in that folder. What's the first thing you have to identify? If it's ionic or covalent. So, Robin, this is a metal and a non-metal, so what type are we working with? Very good. So we're working with ionic, and everyone should know this by this point. What will you not see anywhere in this name? You will not see any prefixes anywhere. So I better not see a tri anywhere in this entire naming system for this particular problem. All right, so Robin, you've already told me that it's a metal. You've already told me that it's chromium. So I'm going to go ahead and write chromium. Now, there's one little special thing that may have to be put in ionic bonds with a metal that we sometimes use and sometimes don't use. What is that little special thing? A Roman numeral. Robin, what things need Roman numerals? Transition metals. Is chromium one of those transition metals? Yes. And I'm telling you now, this is the hardest type of problems to name. If you can do these without any hesitancy, you can do any naming compound at all. Yes, ma'am. Matter of fact, let's answer that question out loud because a few people in first period kind of got a little confused with that. So I'm actually going to do it a little different. So my first question is, what is this line right? That's the stair-step line. What does it separate? Metals from non-metals. All right, so very good. So here's another way to look at it. What I'm fixing to draw are, well, let me draw it first, and then I'll explain. Yeah, I'm sorry. I really can't do anything about it. It drives me nuts, too. You are all intelligent enough to know by this point those things, those elements in the blue boxes, both blue boxes, why are they special? In terms of, say it again. All of those in both blue boxes only have one charge, which means what about their Roman numeral? They don't need one. So here's another way to look at it, Bailey. Everything to the left of this line except what? These two columns, group 1 and group 2, and the mini staircase. So if it's outside of that staircase in these two columns, it has to have a Roman numeral. I will tell you this when you get to college. There are a few more. These are the only ones that you got to know for me. Okay? So just kind of throwing that out there right now. So does it help to see this little bitty mini staircase, right? You already know silver and zinc and cadmium. We'll just go up one more step. And what's the one we always talk about? Aluminum. It doesn't need one either. And gallium and indium just happen to be included in that, and I know that for a fact, so I'll just make it a little mini staircase. Yeah, but if you'll just memorize their locations, you've already memorized these three, right? Hopefully, just add those three to the list. It's just that third step. Do not need Roman numerals. Yes, ma'am. So if they're in those mini stairs or those two columns, do not put a Roman numeral beside it. Yeah, you need to know. That's actually another thing. Let's talk about that. What is silver's charge always? It's just one. Well, how many stairs is silver? One. What is zinc and cadmium They're both 2 pluses. Well, how many tall are they? 2. Well, Well, what is that one? Okay. All of these are all 3 plus, and it's 3 elements. So that may be another way to remember. So it's 1 step is 1, 2 step is 2, 3 step is 3. Those are the only charges they'll ever have. They will not have anything. Yes, ma'am. Yes, ma'am. And obviously, group 1 is always 1, group 2 is always 2, and then it's 1, 2, and 3 again. So those are all the exceptions. Yes, sir. For me and my class. Okay? All right. So let's go back. First of all, we're working with chromium, correct? Chromium is right. Let me change colors. Do it green. Is chromium anywhere in that blue? Nope. So we got to figure out what the Roman numeral is. So here's how we do it. I'm going to go ahead and write this. I'm going to put a blank right here because I know I got to fill that in. Now, Robin, chlorine turns to chloride. Very good. Now, Robin, why did you not call it trichloride? Very good. It's not covalent. It's ionic. So here is where we have to figure this out. This is the location for the Roman numeral. And I'm begging you now to know this. What does the Roman numeral actually represent? Very good. It's the charge on the TM. So Rn is the charge on the TM. The Roman numeral is the charge on the transition metal. Well, here's the deal. Charges comes with positives and negatives, correct? I see no positives or negatives up there. So here's the process that we determine it. It's called reverse crisscross. Thank you, ma'am. Okay. Like a railroad crossing sign? Crisscross. Yeah, you've never seen that? What are you talking about? Woo! All right. So here's what we got to do. What is technically behind? I'm going to erase this in because I don't need it anymore. So we've got a 1 technically right here. So what I'm going to do is I'm going to pull it backwards. And then this 3 technically belonged to who? It belonged to chromium. Now, but here's my next question. I know that I've got a 3 here and I've got a 1 here. But it's important we know that the signs. Which sign is always first, positive or negative? Positive. The cation, very good, is always first. Now, this is why this problem is the hardest one to do, what I'm fixing to show you. You must always, first of all, chromium. Can chromium even be a 3? Can be a 2 or a 3, so that's possible. But remember, we've got to check this thing right here. All right, so that's a good question. So what do you mean? How do I know if chromium can be a 2 or 3? That's the only way you can do it is memorizing it. Remember that bottom box, the polyatomics? Now here's the deal. That's what hang on. Here's the deal. You don't have to know all of the possible charges. That's just one other key indicator. The thing you do have to know, you have to know that one without any shadow of a doubt. You've got to know the charge on the anion. Otherwise, you're not going to be able to do any of this. Hang on one second, okay? How do I know that chlorine is supposed to be a -1? It's in group 17, and all group 17s are -1. Well, if this is right, then that is right. Then that means the cation is also correct. Yes. So, now that I know that that is correct, what is my Roman numeral? 3. Now let me pick on somebody. Tristan, what is the Roman numeral for 3? Now, just for my sanity, please put the bars on top and bottom. Do you have to have them in parentheses? No. Yes, ma'am. Uh, 13 is always a 3 plus, and 14 is a weird, strange animal. We'll talk about it later. Okay. Very good. Okay. Any questions on this? So this is chromium 3 chloride. All right, now let's look at the next one. RNF2. I'm forewarning you right now. On the test on Thursday, I have 2 that are back to back, just to trip you up. One of them is RN, and the other one is RA. Put your you got 2 fingers, right? Hopefully you got 10. Take 2 fingers, put one on RN and put one on RA. One on RN and one on RA. Shh. Find them. One on RN, one on RA. There's an RN and an RA. And I do this on purpose because which one is this question asking about up here on the board? It's RN. Which finger is the RN under? It should be your right finger. Now, what group is radon in? 18. I'm telling you now, I'm doing this to mess you up because since this is in group 18, the very next one will be RA, and you've got to make sure that you catch the differences. Because you told me that it's a noble gases, so that means it's a non-metal, correct? Okay. What is F? It's a non-metal. So what type of bond are we working with? This is covalent. Very good. So since we're working with covalent, what must be present? Prefixes, okay? So the very next one, if it was RaF2, what type of bond would that be? That'd be ionic. And I think, as a matter of fact, I think actually on the test, I don't remember what it is, but it's like Rn and something, and then Ra in the exact same compound, or the exact same element, to make sure that you catch the differences between those two. So, my first question is, and Michaela, back to you. When does the first element have a prefix attached to it? When what's more than one? Yeah, what is that thing called? Subscript. What is right there? 1. So do I need a prefix on it? So what is Rn again? Radon. Not radium. Radon. Okay. Our Emma. When does the second element need a prefix? It's an A word. It's an A word. Always. Always needs a prefix. Okay. So what is the prefix for 2? Di. Very good. And so it's di, and it's not fluorine, it's fluoride. Very good. So di, fluor. So this is radon difluoride. Radon difluoride. Okay. All right, let's look at the next one. We've got K2S. K2S. All right, Ryan Howard, what is K? Is it a metal or non-metal? It's a metal. Sulfur, metal or non-metal? Non-metal. So we have what going on here? Ionic, very good. So what will you not have present? You won't have any prefixes. So K is what again? Potassium. Now, Ryan, is K in one of those blue boxes? It is. So what do I not need on this thing? I don't need any Roman numerals. So that's good news. So I'm just going to keep right on trucking. And sulfur turns to sulfide. That's it. That's all you got to do. Potassium sulfide. Now, so my question to you guys is, why in the world is it not dipotassium? It's ionic. And also, how do I know that there's going to be 2 potassiums? Well, remember, who does this 2 really belong to? Remember, it's 2 negative, and this is 1 positive. So if you do the crisscross method, do you always know K is always a 1 plus? So it's never going to change. Sulfide's always going to be a 2 negative. It's never going to change. So you don't have to worry about the prefixes because the numbers are always going to be that way. Okay? All right, so what I want you to do, I want you guys to do, and listen to this is important. Do we do and you do B, C, both B's and both C's. Do not do either A yet. Just B and both B's and both C's. All right, so let's go ahead and run through these real quick. All right, so Na, NO3. So, let's see. Ashwini, Na, what is Na? It's a metal. What is the name of it? Sodium. All right, so we've got a metal, and then we've got this crazy, funky thing back here. And I've told y'all this since day 2. You've got to know these polyatomics. And they are coming down on you fast and furious if you don't already know them. So we've got sodium. You've already told me this. You know that. So let me ask you this. This is kind of an out loud question. What do we call all of those groups of things that you've been studying? Polyatomic ions. What things make up ionic bonds? Ions. These are polyatomic ions. So that's why this is ionic. So we already know that it's sodium. Now, Ashwini, is sodium in one of our blue boxes? Yes. So what do you not need? You don't need a what? Roman numeral. Very good. And what is NO3? Nitrate. That's it. Sodium nitrate. Simple, straight to the point, really simple. Good. Now, these next three should be very easy, and I'm going to write them down just to make, if you're at home watching this, which you're probably not, ASF3 and then N2O4. Now, so Maya, O and F, are they both metals, both nonmetals, or metal? Very good. So both of them are nonmetals. So what type of bond are we working with? Covalent. Guys, y'all stay with me. Shh. So, does the first one need a prefix? Why not? Very good. It's only one. So it's oxygen. Does the second one need one? Yes. What is it? Difluoride. Okay. Moving on. Natalie. A, S, and F. Now, Robin, you have to be very careful with this. I know the periodic tables that y'all don't have, it's hard to see the stair-step line, but if you have one that you're like, I don't know if it is or not, please make sure you look up there on the wall because it's easily defined. Is it a metal or non-metal, Natalie? It is a non. Fluorine's also a non, so we're working with covalent. So does arsenic need a prefix? Why not? Because the subscript is... Very good. And then F is what prefix? Tri, and it's trifluoride. Okay? All right. Terrell, does the first one need a prefix on N? Why? It's 2. Very good. And what is the prefix? Di. Now, is it dinitride? No, remember the first one keeps its name. You only change the ending on which element? The second one. And what do we do here? Very good. Now, very good. That's one of those funky ones that has a vowel issue. Remember, you drop the vowel on the prefix, not the element, because if you drop the O, it's no longer oxygen. Now, there is one other thing that I want to ask you. If you were in math class, would that be okay in math? No, but let me ask you something. Why did we not reduce that? If you reduced the formula, is it still dinitrogen tetroxide? No. So if you change the covalent formula, you change the name. So you do not reduce covalence, but you do reduce ionics. That may be something you kind of maybe want to jot down because those are a little weird. And you're fixing to see an example of that in the very next one. So again, never reduce covalent, only ionic. I'll be lenient on that. That's one of those things that they're both kind of right. One is correct, if that makes sense. But I'll be lenient on that because it is one of those just grammar issues, but I'm not going to be hard about it. All right, so these are the two that I told you to leave blank for just a second. And there's a reason why. Okay? All right, Johnny, what is SN? 10. Is 10 a metal? Is 10 a metal? Yes. What is O? Is what type of element is oxygen? Non-metal. So we've got a metal and a non-metal, so this is ionic. Very good. You've already told me that 10 is SN. Now, Johnny, is 10 in one of our blue boxes? No. So what does that mean you have to have? Roman numeral. Very good. So I'm going to leave this blank for just a second. We'll come back to it. Now, oxygen, why is it not monoxide on the back part? Very good. So it's what? Oxide. All right, Najee, this is where you really need to kind of focus in on this one because this, awesome, good. You did it fantastic, but let's make sure it's right. So here's the deal. I need my Roman numeral. And again, where do Roman numerals come from? The charge on the transition metal. So here's the deal. Technically, what are behind both of these elements? Ones. So really, we've got one plus and we've got one minus. And this is the situation where students just blow through this and they go ahead and write down 10-1. Well, here's the deal. Now, this is the part where I told you, you don't have to have it memorized, but it helps. Because if you know, can 10 be a 1? It can't be, then a red flag will go up. So if you know that, again, you don't have to have it memorized, but it helps. So you know that this is wrong. Well, if you know that 10-1 is wrong, how do you fix it? You've got to fix this part first. Perfect. That's the part that you can do. Now, I'm preferably, I do it that way as well. I take this first. So here's the deal. What must oxygen be? It's got to be a 2. So multiply both things by 2. That changes this to 2 plus. That changes this to 2 minus. Now they're both correct. So which 10 are we working with? 10, 2. Very good. Now, if you've already done the next one, great. But I'm going to change it up a little bit, just slightly. I want you to change it to this. The only change is add a little 2 back there. If you want to redo it, it'll help you even more. See if you can do that one. Makes a bit. If you do it, you'll see the difference. This is what we're working on. All right, Brett, what is PB? It is lead. Is lead a metal? Is it a transition metal? Yes, so what does it need? Roman numeral, very good. So why is this not lead something dioxide? Very good, it's ionic, so we're just going to write oxide. So again, this time we got to figure out what our charge is on our Roman numeral. So what's understood to be behind PB? A 1, so that's 1 minus. We got to pull a 2 up, so remember it's just reverse crisscross. But again, the thing you've got to check is that number. Is that right or wrong? That is wrong. What is it supposed to be? A 2. So if we change this to multiply it by 2, this now turns into 4 plus, this now turns into 2 minus, and so now we've got lead 4, which is what Roman numeral, Massimo? How do you do Roman numeral 4? Very good. Again, don't mess that up. Do not mess that up. All right, so we good with that one. All right, let's work some more practice.